Now, what if we wanted to verify not only if we have connectivity, but the path that was chosen to get to that destination? Well, we can use traceroute to do that. Traceroute. So in this example, we typed in traceroute 10.10.50.2. 10.10.50.2. So what type of messages are we sending with traceroute? Well, it really depends on the way that traceroute has been implemented on that particular product. I've seen it implemented using ICMP messages. I've seen it implemented using UDP messages. So regardless of the type of messages that are used, we're just going to call them traceroute messages, all right? Traceroute messages, because it doesn't matter. The key here is that we're focusing on a particular field in the packet called the time to live field in the packet. So regardless of whether it's an ICMP message or a UDP message that's being used here, we're still looking at the packet eventually at the time to live field. Time to live field, the TTL field. So here's what happens. My device that's initiating the traceroute creates the traceroute packet. And the traceroute packet is going to be sent out the interface to the destination. So out the local interface right now to the destination of 10.10.50.2. And the time to live is going to be 1. Just 1. That means the packet expires as soon as the first router touches it. So what happens now is that when the router gets this traceroute packet, it decrements the time to live and says, oh, well, I can't forward it now. So what does it do? It responds back with a time to live exceeded message. So now my device here of R1 says, I just received a time to live exceeded message to my traceroute, and it came from 10.10.10.2. And I do this 3 times. That's right. So there's the first one I send, second one I send, third one I send. So I did this 3 times. I sent 3 traceroute packets with a time to live of 1. They all time out. The router responds back to me 3 times. One of them took 0 milliseconds to talk. Well, 2 of them took 0 milliseconds to talk or exchange, and one of them took 1 millisecond. No big deal. That's great numbers right there. That's our first hop. So now what do? Once I've completed this first line, I then go on to the next line. And the next line in this case is going to have a time to live set of 2, right? Because I want to make sure I get past the first router now. I want to get to the next router along the path, the next layer 3 device. So when I set the time to live to 2, I send out my 3 traceroute packets. The first router gets them, decrements the time to live by 1, and forwards it on. Perfect. The next hop router gets it, realizes that when it decrements the time to live, it's now 0. Time to live exceeded. So now it sends back a time to live exceeded message to the device that sent the traceroute initially. And it comes back to me here and it says, well, 10.10.22, right, has just sent you those 3 time to live exceeded messages. Great. So you notice what I'm just essentially doing here. I'm building a list of devices that respond back to me. So now that I know 20.2 just responded back to me, it's still not 10.10.50.2, right? I'm trying to get to 10.10.50.2. That's what I'm trying to get to. So let's do it again. But now we're going to set it to a time to live of 3. And then when that finishes, time to live of 4 and 5 and 6 and 7 and 8. And we just keep doing this until, look, we got our response. That is part of this particular network here. We're good. So essentially, we're looking for a response from the router that owns the network wherever that device lives. So if that's a PC that we're trying to trace route to, then we're looking for the router that's connected to that network to respond back to us and say, hey, yeah, right here. And then our trace ends. And when our trace ends, we're done. It's over. We're finished. And then we know what path we took. We went from 10.10.10.2 to 22 to 172.16.02 to 10.10.82, 10.10.42, and so on and so forth in order to get there. So let's go ahead and do a trace route on a PC right now and see what happens. So here on our Windows PC, Windows 7, I'm going to type in trace RT and 192.0.2.1. So in this case, what's going to happen? We are going to send out our trace route packet. You'll see we got our 3 responses here, and it came from 10.1.1.1. Then we had 3 responses come back, and it's from 10.1.12.2. That's R2. Send 3 more. and the response is coming back from 192.0.2.1 in this particular case. So there's an example of doing our trace route. So I know exactly the path that's being taken by these packets to get to that particular destination network. But we are here, in this case, this using the top trace route, the source of the trace is coming from the exit interface. So the destination of the trace route packet is 10.10.50.2, but the source is whatever the IP address is of this interface. If for some reason I want to do the trace from another interface on my local device, I can update the source. So instead of using the exiting interface, I could say use whatever other interface I want to, and then that will verify if I have connectivity from other LANs, other networks connected to that particular router, whichever ones I choose.